All right, moving right along to lesson 3.2, we are going to be solving today by substitution. So starting out today with just a similar problem from yesterday, what values of A and B would make the system have no solution? So no solution, we want them to be parallel. When they are parallel, the slopes are the same. So that would make a slope of 2 for A. The y-intercepts, however, have to be different. So anything except for 9. So we could say 10, 11, 12, etc., etc. To have infinite, the lines have to be exactly the same. So your slope would also be 2, but your y-intercept would also be 9. So now I just have the exact same equation. They would graph directly on top of each other. Okay, so we're given that y is equal to 35, and then we're given that x plus y equals 50. So what I'm going to do, like we said earlier, this is solving by substitution, and it's exactly what it sounds like. I'm going to take what y is equal to, which is 35, and substitute it in my next equation to solve for x. So I'm going to say x plus 35 equals 50. And now I can subtract 35 and find that x equals 15. So now I have an actual solution to my linear equation. I have the point 15, 35. So when they give you y, that makes it super simple, right? All I have to do is substitute it in the second equation and solve. Nice and easy. If I'm given one like this one, where I'm given y equals 3x plus 2, I'm going to follow the same steps. I know what y equals, but y equals a bit more than just a number. So what I know right now is that y equals 3x plus 2. So I am going to still substitute that in my equation, but when I do, it's going to look a bit different. I'm going to say x plus 2, and now instead of y, I'm using this entire chunk, 3x plus 2. And this now equals 11. So I finish out this entire equation. The only thing I replace is the y. And then I can solve. X plus, I distribute, 6x plus 4 equals 11. X plus 6x makes 7x plus 4 equals 11. Subtract 4. Seven x equals 7. We divide by 7. Sorry, my computer gets a little laggy sometimes. And x equals 1. All right, that's great, but I'm not done because we know that solutions to systems are ordered pairs. So now that I know that x is equal to 1, I'm going to go back here and say y equals 3 times 1 plus 2. So that I can get y equals 5. So I can write my solution as an ordered pair. 1, 5. So once you get your value for one of your points, you're not done. You have to substitute it back in to get the second part of the ordered pair. Okay, a couple more steps now. I've got x minus 2y equals negative 6, and negative x plus 6y equals 18. So I actually do not know what x equals or what y equals. But I can change one of my equations to find out what one piece is on its own. So if I go over here and I add 2y to both sides, now I have x alone. Now I actually do know what x equals. X equals negative 6 plus 2y. So I can go into my second equation and substitute all of that in for x. So this one's going to be a little bit trickier because I have a negative outside. Oh, didn't mean to use a highlighter. I have a negative outside. So what I'm going to do here is write negative, and then I'm going to rewrite everything that x is equal to. Negative 6 plus 2y. And then I'm going to finish the equation. Plus 6y equals 18. And the reason I wrote that negative on the outside is because we remember from our first unit that I'm going to have to distribute my negative, so all of my signs will change. So let's go ahead and combine like terms to get 4y. 6 plus 4y equals 18. Subtract 6 to get 4y equals 12. And divide by 4 to get that y equals 3. So now I know that y equals 3. I'm going to go up here to where I have what x is equal to. And I'm going to substitute in 3 for y. So x equals negative 6 plus 2 times 3. And we get x equals 0. So our coordinate is 0, 3. So lots of algebra, lots of solving equations for solving by substitution. Okay, I have 2x plus y equals negative 2 and 4x plus 2y equals negative 4. So again, I'm going to have to get one of my variables alone. And looking at the equations, it's going to be easiest to get this equation to have one variable alone because y doesn't have a coefficient. So all I have to do to get y alone is subtract 2x. So that I get y equals negative 2 minus 2x. So now I'm going to take everything that y is equal to, and I'm going to substitute it in for y in my bottom equation. 4x plus 2 times negative 2 minus 2x equals negative 4. We distribute and solve. Okay, I've got 4x minus 4 minus 4x equals negative 4. So obviously my variable is going to cancel out. 4x minus 4x is 0. And I get negative 4 equals negative 4. So I'm left with a true statement. Whenever I'm left with a true statement, I have infinite solutions. When am I going to be able to write that? Okay, there we go. Infinite solutions. So let's take a look at these equations. If I were to multiply this top equation by 2, it looks like I would get the exact same thing on the bottom, right? 4x plus 2y equals negative 4. And so we know that if I have the exact same equation for both, it's infinite solutions. So the solution to a system is always a point x comma y. So when you're using substitution, you're looking for either x equals or y equals in one of the equations, and you're substituting it into the other one. If you don't have that, you should be able to isolate a variable in one step with at least one of the equations. We don't have any word problems, so we don't have to worry about that. But make sure to always go ahead and solve for the other variable that you didn't get in the beginning.